All right, hi everyone, and thank you for joining our very first test talk. So before we start, just a quick housekeeping for best viewing quality. We do recommend that you use Google Chrome as a browser and closing any other programs running in the background. So for this session, which is the very first series of 4 online discussions that will bring together experts from across the telecom industry, and they'll be sharing valuable insights on key trends, testing challenges throughout the design, the test, and manufacturing. And we'll be covering a wide range of topics, including photonics, integrated circuits, 400 gig, 800 gig technology, as well as 5G transport testing. My name is Sophie Legault. I'm Director of Product Management at EXFO. And in this first session, I'm very happy to host 2 very special guests. Our first guest, Stephen Hardy. Hi, Stephen.
Hi, Sophie. Thank you for having me here today.
Great. So Stephen is the Editorial Director and Associate Publisher of Lightwave and Broadband Technology Report. Stephen's responsible for establishing and executing editorial strategy across both brands. He's covered fiber optic space for more than 20 years and communications and technology for more than 35 years. So very glad to have you here, Stephen.
Thank you.
Our second guest is Stéphane Chabot. Hi, Stéphane.
Hi, Sophie. Good morning, good afternoon, good evening, everyone.
Great to have you. So Stéphane is a Vice President Test and Measurement at EXFO. And in his role, he's responsible for developing the worldwide business, strategy, and vision for the test and measurement solutions. And Stéphane has been in the telecom industry for over 20 years. So really great to have both of you as guests. So the topic for our first session is all about disruption. There are many significant changes that are hitting the telecom industry all at the same time. The content service providers, they have to launch complex, high-speed broadband and 5G networks while facing very high demand on the bandwidth side. And with that, they need to adapt to new technologies. And the key telecom players that are designing, testing, and manufacturing these new networks really have to adapt also and rethink their methods and their models. So we'll first hear from Stephen on these new trends and how they affect the design and manufacturing. And following that, we'll do a Q&A session with Stephen and Stéphane. And we'll also open up to discussion with audience questions in the last 10 minutes. So please don't hesitate to put your questions into the chat line, and we'll go through these questions at the end of the session. So on that, I'll switch it over to Stephen. So over to you, Stephen.
Very good. Thank you very much. Hello, everyone. As Sophie mentioned, what I'm going to do here today is, for the next 15 minutes or so, give you an idea of some of the technology trends that I'm following that affect design and manufacturing, and obviously test and measurement as well. So while today's theme is dealing with change, I'm going to start by talking about the fact that this change is happening on a set of requirements that seem to be pretty much immutable. Once we get that out of the way, we'll talk a little bit about some of the trends in component and foundational technologies that we're seeing in the business, as well as trends at the systems and networking level. So as I said, while there's a lot of change obviously going on in the optical communications field, there are some things when it comes to customer requirements that seem never to change. For example, network operators always want faster transmission rates. They want longer reach. They want it lower power, they want a smaller footprint, they want lower cost per bit, and increasingly lower latency and more interoperability. And of course, in all likelihood, if you can do it, they want it all at the same time. And for you folks that are in the design field, good luck with that. So what we're seeing as far as change are some trends in terms of how folks like you are dealing with these foundational networking requirements. So for example, we're seeing a lot more in the way of complex modulation formats. So of course, coherent is probably the most salient example of this. And we're seeing the application of ever-increasing baud rates. We're seeing those paired frequently with proprietary algorithms, particularly among the system providers who have their own in-house DSP expertise. As a matter of fact, frequently here we're seeing what could be thought of as kind of a witch's brew of different modulation formats paired with primary algorithms, forward error correction, use of different kinds of subcarriers, different takes on constellation shaping, et cetera, et cetera. This has reached a point where a couple of years ago I was reporting on a new technology announcement by Sienna. And so I contacted them and said, what modulation format are you using? And they said, quite frankly, we've decided we're no longer going to discuss modulation format because there are so many in-house spins on this that it really doesn't mean much anything anymore. So this is particularly true at the line card level. In addition to what we're seeing in the mainstream that's enabling things like 800 gigabit per second coherent, there are other coherent related initiatives that are kind of bubbling below the surface that we could see have an impact on the marketplace sometime in the next few years. Once the whole concept of coherent light, which has been thrown around a bit by some of the major internet content providers, is the idea that potentially there might be a way to get some sort of stripped down, simplified, and therefore low cost version of coherent that might prove useful at some point in the future in data center networks. Another interesting initiative that hasn't gotten a lot of attention, I don't think, outside of the cable MSO circles, is an initiative from Cable Labs to look at a means of applying coherent technology to the feeder networks in hybrid fiber coax applications. The goal here is to enable particularly older fiber to support transmission rates not only potentially of 10 gigabits per second, but higher along the lines of 100 gigabits per second, which with longer reaches, particularly as distributed access architectures are rolled out in cable MSO networks. So interesting things to look at for the future. And inside the data center, of course, outside of the coherent world, we've seen non-return to zero on-off keying give way to PAM4 as we've gotten to 100 gigabit Ethernet and greater speeds. As you're probably aware, while we're just rolling out 400 gigabit Ethernet now, the IEEE is already starting to work on what comes next. There's a study group called Beyond 400 Gigabit Ethernet. And Lightwave was fortunate enough to host the leader of the study group, John D'Ambrosio, and some of the people who are going to be working on this initiative on a webcast about a month or so ago. And of course, we're talking higher speeds. Again, you might potentially be talking about different modulation rates. So during the course of the webinar and some of the preliminary discussions, I was hearing PAM6 thrown about, PAM8 thrown about. So PAM4 in all likelihood is not going to be the last application of pulse amplitude modulation for higher speed Ethernet. Now, in addition to the greater complexity in terms of transmission types, we're also seeing an increase in integration at the component and subsystem levels. So in some ways, this is a means of getting at that smaller footprint and potentially lower power, and to some degree, in some ways, decreases complexity because you're integrating everything into a single device, but in some ways also increases complexity because that single device becomes the home of an increasing number of functions. So certainly the hot button buzzword in this space is silicon photonics, and we're seeing silicon photonics being applied more and more frequently in a wider variety of applications. But I should point out that there's still life in indium phosphide approaches, and so we're going to continue to see both being used for the foreseeable future. In addition to these materials approaches, there are folks, as you're probably aware, that are working on the application of polymers that potentially could be employed alongside silicon photonics and indium phosphide, which again would just add another material structure that would have to be dealt with. Regardless of whether you're doing silicon photonics or indium phosphide, but in particular, if you're doing silicon photonics, one of the challenges is getting light into that photonic integrated circuit. Depending upon the approach you're using, you might be facing or thinking about, flip chip bonding. You might be thinking about edge emitting. Some silicon photonics developers, of course, have figured out ways of being able to stripe some of the photonic material into the standard wafer process, so the laser is somewhat integrated into the wafer. And so, each of these carries their own challenges when it comes to ensuring that the design is working properly and the finished product is working properly. The other challenge, of course, is once you get the light into the chip, you have to get it off the chip and into the fiber, if we're talking from the transmission perspective. And so here again, coupling the fiber and ensuring that you're getting an efficient transfer of light into and out of the fiber is a challenge that every designer has to deal with. Along these lines, we're starting to hear a lot more about co-packaged optics. So here, the idea, if you're not familiar, is be able to move the optics as close as possible to the, in most likelihood, switch silicon to be able to deal with the higher input and output rates that the future generations of switch chips are going to require. So the issue here, first of all, is when is this going to be needed? There seems to be some consensus around the industry that once we get to 51.2 terabit switch chips, co-packaged optics might make sense. Of course, you're looking at very small optical packages when you're talking about integrating optics, close to the chips, and you have issues that are raised not only in terms of the small size, but ensuring that these devices work properly. Reliability obviously is going to be huge, because if something goes wrong with even one of these little chiplets, that basically could knock down the entire application. Along these lines, we've seen some interesting approaches discussed. For example, there are some people with this in mind who are suggesting that perhaps the light source should not be integrated with the chiplets right up against the switch chip, and perhaps could be remoted in that way. Basically, if the light source needed to be replaced, or something else went wrong, it'd be easier to deal with that, and therefore you wouldn't have to replace the whole board. But there are drawbacks to this approach as well, and so we're seeing a lot of development here. We have seen some demonstrations. We're likely going to see more, and this is an area that's going to be the subject of a significant amount of investigation and development over the next few years. Now, conversely, at the systems level, we're seeing a move towards less integration. If you've been in the business for a while, you may remember the era of the God box, where you had a platform that could do theoretically just about anything when it came to optics. What we're seeing now is a very strong move away from that towards the use of open and disaggregated platforms. So here, basically the ability to have more module building block kinds of approaches to optical transport systems. There are several benefits touted for this approach. One, of course, is operators only have to pay for the functions they need at any particular point in time. Greater flexibility there. Obviously, it promotes kind of a pay-as-you-grow approach, which makes the business department happy. You also have the potential ability to assemble best-of-breed building blocks together, particularly if everybody's using open APIs and an open approach. You also can more rapidly take advantage of technology advances in particular areas of functionality. So if there is an advance in optical switching, or transmission rate or whatnot, you don't have to replace the entire platform. You just have to replace that part. Needless to say, particularly if you're talking about best in breed, this is going to promote a multi-vendor environment, which is something that operators have long requested. That means, of course, interoperability is going to be a absolute requirement. Obviously, there are a fair number of standards organizations, industry organizations, the Open Compute Project, the Telecom Infra Project, that are looking at this, but also there are a number of vendor-led initiatives, within particular companies that are offering this kind of an approach as well. So, this approach kind of was born in the data center market and is now moving into the service provider space. And it kind of opens the question about whether white box platforms might start seeing some degree of traction in the service provider space. Certainly in the data center, we're seeing more bare metal switches and kind of white box approaches to switching technology. And so one question that is still a matter of debate is where, if at all, white box optical platforms might make their appearance. So something certainly that I'm looking at covering in the long term. And of course, another thing we're seeing is the rise of pluggable transceivers, particularly coherent pluggable transceivers for service provider applications, as well as data center interconnect. In particular, this approach pretends to finally deliver the promise of what's been touted previously as IP over DWDM, or what Cisco recently has recast as routed optical networking. And that, of course, is the ability to plug coherent optical transceivers directly into routers and potentially be able to obviate the need for some standalone optical transport systems, provide a little bit greater possibility of IP and optical layer integration, and control of networks at the and services at the IP layer, potentially paired with automation as well. So again, interesting trend that's definitely one that we'll be watching in the future. Speaking of automation, another trend we're seeing is an increasing use of software in the network, which again can enable a variety of benefits. That increased automation I talked about, greater intelligence within the network, potentially to take advantage of that automation. Maybe networks can be either self-configuring or be able to at least complete some of the configuration or reconfiguration functions on their own without manual intervention on every single step. This potentially would imply some sort of analytics capabilities, particularly if this is something where the network is going to be asked to be able to react to, for example, potential faults or actual faults in the network automatically. The ability to sense what's going on in the network and react accordingly is going to be important. And then, as is the case for the last few years with the growing interest in software-defined networking and network functions virtualization, is looking at which functions might make sense to virtualize and how those virtual functions could be managed, employed, and troubleshooted if necessary. So, wrapping things up, overall, we're seeing increasing complexity, particularly when it comes to transmission rates, that needs to be managed and coordinated in the network. That means software and some degree of automation. The importance of standards and MSAs and conforming to those standards and MSAs becomes more salient. The question is, can some of this complexity be avoided? And of course, that opens some avenues for innovation. And as I said at the start, this is all on you folks, and good luck with that. And so with that, let me the program here, or the slide deck here, and turn things back over to Sophie.
All right, thank you very much, Stephen. Very interesting. Clearly, the pace of that innovation and those changes are creating questions, challenges, and probably headaches to the industry, and obviously for equipment vendors and the manufacturers that need to follow that pace. So thank you for that. So we'll now go into our Q&A discussion. So my first question will be for Stefan. Stefan, so Stephen discussed more about integration of the components at the subsystem level, and the challenge of and the questions of do we need to integrate everything or just part of it? How close? How much do you integrate? From a testing perspective, what are the key challenges that this brings to equipment manufacturers, and what would be a good approach to solve these challenges?
Yeah, thank you, Sophie, and again, thank you, Stephen. Very interesting key trends that you've highlighted. That was very good. Thank you very much. So, Sophie, linked to your question, indeed, it's a very important one and a key disruption that's happening to the market right now. And as Stephen highlighted, also most customers are already, telling us that they have these challenges. Into the transceiver example that was just mentioned, if there's an issue, before you could simply change the plug, but with co-packaged optics, as we were just referring, in the future, this won't be possible anymore. Because it brings a lot of new challenges compared to the traditional transceiver, or like into one of the sessions that we have just a bit later on tiny PICs, tiny PICs-based transceiver manufacturing that changes the entire landscape of testing, because now, as we're saying, the packaging is now a chip. So from wafer parametric testing at the foundry to final production and final product QA and testing, you actually need to design for testing and with everything in between, and be very careful with those testing needs to happen at each step of the development chain. I'm sorry. Because reliability needs to be maintained, of course, but the challenge, if you integrate more functions into a device, as we've just shown, for example, with those two examples, it becomes more complex and more could go wrong. And as with all of us having a lot of experience into the market, the sooner you can actually detect where the fault is, instead of being at the final solution or final product or final transceiver. For example, if you have a faulty one, root cause analysis and being able to detect it as soon as you can into the entire manufacturing chain is critical. So these are some of the critical new challenges that manufacturers have today.
Great, thank you. Indeed, quite the challenge. Stephen, any comments on Stefan, on the challenge highlighted by Stefan?
Well, certainly one of the benefits that have been touted for things like photonic integrated circuits and silicon photonics is the ability to potentially decrease test costs by being able to test devices at the chip level. So obviously, the people who are working on this are going to want that kind of a capability. And of course, accuracy is going to be key. Another thing that Stefan discussed that I think would be of particular interest is the ability to record and be able to analyze the root cause of particular failures, and be able to keep track of whether you have a consistent failure that's showing up over and over again, that might signal that there's a problem with the design or perhaps with the manufacturing setup that needs to be addressed before you end up with a bad run that can be expensive to fix and or replace, it would seem to me.
Good, thanks. Yeah, and obviously it does bring a lot of challenge, but in the end, the benefits that will come with that integration, it probably outweighs that challenge, and the solutions. There will be solutions developed to make sure that production is successful. All right, thank you. Let's move to our second question. So again, to Stéphane. So in a completely different direction than the component level, we're seeing more integration. Where we're seeing more integration, Stephen highlighted that at the system level, we're moving what he called from the God box to a more disaggregation, and then with that, the objective of that disaggregation is really to have more flexibility, to combine, as Stephen was saying, best of breed technology, speeding up innovation, and this will create a lot more multi-vendor environments. And also this will drive significant need for interoperability testing and validation. So how do you see that, Stéphane, reflecting in the testing strategies?
Thank you, Sophie. Yeah, absolutely, and it's a good point. I really liked also Stephen's reference to the God box. It brings back good memories. So yes, so indeed, those MSAs and standard ecosystems are becoming extremely important right now, and very quickly, I have to say. And we saw the same thing on the software side. And more interrupt testing, as you mentioned, Sophie, with different plug fest are trending very fast right now, where vendors, they will want to get together and verify the performance of their combined solutions for overall network performance, and within standards, of course, and MSAs, but also to help everyone to also work outside of standards. And as Stephen referred to, organizations like Open Compute, or some of the ones that we're following on the test and measurement side, for example, HORAN or Ethernet Alliance, which we are a member of, for example, will drive many of these, interrupt plug fest, and that are extremely important within the industry. And validating interoperability will become actually a competitive advantage for technology players at the manufacturing and at the solution level, as players will need to prove their possible integration in all those multiple environments. So, which means actually the need for more testing every step of the way or at each level, as you were referring, Sophie.
Okay, thank you, Stéphane, and maybe for Stephen, in your discussions, have you seen that this interoperability testing? Do you see this as being driven by the manufacturers or more from the end customer perspective, or are the manufacturers realizing they have no choice? Have you had interactions on that?
Well, I think what's going on is probably most directly related to your last point. As I think I mentioned in my presentation, network operators have wanted interoperability for a long time, and even standards and whatnot that were meant to promote interoperability sometimes didn't fully accomplish the tasks as individual vendors tried to push the envelope a little bit in order to differentiate their products. So I think what we're seeing now is the network operators really putting their foot down, particularly as technology is changing. They're seeing an opportunity to really demand interoperability, and also the benefits that things like open disaggregated systems will bring are pretty much impossible if you don't have interoperability. So I think the technology development community has heard this message loud and clear. And so we're definitely seeing the adoption of open APIs and greater adherence to various standards and MSAs. The challenge for some of these technology developers is trying to figure out which MSA or which standard they should be testing against, particularly as we get into new areas. If you look at 800 gig coherent, there's work underway in the OIF and other standards bodies. At 800 gigabit Ethernet, there are at least 2, if not 3 MSAs out there that are promoting some sort of standards, as well as another group that's looking at laser technology that could be applied to that. Certainly when we entered the era of SDN, you had Open Daylight, and you had the ONF, and you had various others industry bodies, trying to get together to either tackle a piece or, in some instances, overlapping pieces. So the challenge for the vendors is basically going to be, so what are the rules, so that I know which rules I should be following, or trying, which specifications I should be trying to meet for interoperability in a particular area.
Yeah, absolutely. Very, very interesting. And yeah, I think we're seeing it across the entire industry. Another example is with ORAN, where it was driven initially by the service provider. Only smaller vendors participated, and now we're seeing there's practically no choice but to participate and be involved in that area. So we're really seeing from the component all the way to the whole system level. So interesting. All right, so our third question is to you, Stephen. So as you mentioned, we're seeing growth in coherent transceivers, with the added challenge of many proprietary algorithms. I liked it. You called it the witch's brew, which is self-explanatory. Different modulation formats and implementation. So do you see this as a temporary challenge, or will that continue to increase as the industry moves forward?
So this is an interesting question for the technology development community. In some ways, it harkens back to the statement I was just making. As I said in the presentation, a lot of what we're seeing here as far as the witch's brew is happening at the line card level. And in particular among systems vendors who have their own in-house DSP capability. And at the transceiver level, the challenge for the development community is that you will have specs, whether they're MSA specs or potentially IEEE or OIF specifications that you'll have to meet. But if everybody's meeting the same specs and building the same product, you quickly come to a level of commoditization, and therefore getting a return on your R&D investment because it's a challenge. So for a lot of times what we see is vendors trying to find some way of, on the one hand, being interoperable, but on the other hand, providing some degree of differentiation when it comes to performance. And so the challenge is, what can I tweak safely to provide a point of differentiation for my product and still meet the interoperability requirements that my customer is going to demand. And so the room for wild innovation and coming up with your own totally unique approach is going to be easier at the line card level, but to some degree, at least being able to do some kind of tweaking at the transceiver level is going to be important for the business cases for these technology vendors to participate in some of these standard transceiver markets.
Okay. And if I go back to Stefan, how because there will always be a bit, at least, of differentiation, as Stephen has mentioned. How do you see that reflecting on from a test and measurement perspective and your customers?
Yeah, thank you, Sophie and Stephen. I could not agree more, and that's why on my side I was referring to MSA, but inside standard and outside of standards, and the small customization or tweaking that everyone will try to bring is a really key one. So I couldn't agree more onto that one. So, Sophie, linked to your question, I think what is constant is that pushing the limits of transmission capabilities are endless. We've seen it for the last 50 years. And actually, when Stephen referred to some of the vendors stopping to talk about modulation formats, and it's a good point. I remember, I think it was around 2008, where on the optical transmission side, where phase of light was actually brought into coherent transmission, which was an RF technology for decades, but that was brought into the optical domain. If we remember, for example, 16 QAM, DPQPSK, or and all of those tons of different formats that saw the light at that time, or Stephen, as you were referring to, for example, even a custom special dual 56 gig or things like this, everyone would have their own spin into something like this that actually changed the entire transmission capabilities at that time also. And linked to your point, Sophie, so with new coherent pluggables, with ZR or ZR, depending where we come from, those needs will explode over the next 4 to 5 years until the next revolution, as we've seen. But talking about, on everything that we've spoken for the last 40 minutes now, and as one of the key pain points, as mentioned earlier, is that still with all of those manufacturing of next-gen solutions, still the sooner we can find an issue or RCA, root cause analysis, into the overall end-to-end process, the less costly it is. So, which is of paramount importance, whatever technology is being brought. And for this, one point I haven't mentioned yet, but that is really important, is to have a complete end-to-end manufacturing test portfolio, integrated, including electrical and optical. Because as to the 3 or 4 examples that we've mentioned so far, I think where we've highlighted how important that was, and to have a unified testing approach, which historically, you might do one part, let's say for RF with one vendor, the electrical part with another one, the optical part with another one. But now, with all of the integration and the alignment challenges that Stephen was also referring earlier, it becomes, the integration has never been as important as it is right now. And equipment manufacturers, they want test vendors that can be partners into that full endeavor. So bringing the entire solution, including the alignment piece, the automation piece, and all of those for the long run. So that's it.
If I could just interject again for a second, the other wild card here, of course, is who's the customer. Certainly it's not unprecedented that particular customers may approach a vendor and say, all right, so I want this, basically to the specs that are standardized, but if you could just tweak this little part here, that would make my life so much easier. Or, for example, you're trying to serve certain internet content providers who have a habit of going off in their own direction. That obviously provides something of a twist on this. And so from the test perspective, I would think, again, flexibility and the ability to meet that customization need, or that single really big customer need that's not quite what everybody else is doing, would obviously be important for the technology development community as well.
Yeah, that's a great point, Stephen. Sophie, if I might just also add to that one. And you're right. And with Sophie, actually, when we plan our 12 months roadmap, let's say from a high speed or technology standpoint, the least we could say is that these on those custom demands sometimes will change dynamically. And our 3 to 6 months is exactly optimized with those key specific requests. So that's a great point, Stephen. Absolutely.
Yeah, definitely a challenge. All right, so we're running kind of a bit short on time, so we'll go to our last question. I don't know if we'll have time for the audience questions, but we will answer them offline if we don't. So I'll quickly go to our last question, which is to you, Stefan. And we'll try to do it quick. So Stephen mentioned that networks now need to be built day one with intelligence, software control, virtualization, and automation. How's that reflected for your customers in the test and measurement world?
Yeah, absolutely, Sophie, and I'll go quickly. So at the manufacturing automation level, but also at the field automation or deployment standpoint, analytics, KPIs, and almost real-time dashboarding and AI, that's starting to trend, are major trends in tomorrow's networks. And to speed up manufacturing and get the full potential of analytics, as Stephen was also referring earlier, manufacturers should consider, implementing efficient and lean automation at all levels of operations, as we'll discuss, very soon. And plan according to those upcoming practices in the test and measurement industry. And that includes testings where our customers want the capability to automate their testing throughout the entire food chain, as we said, from development to manufacturing and in-service phases. And finally, the last key point into that one, as Stephen also mentioned, is, and you too, Sophie, is that intelligence and software control is becoming of paramount importance, and where technology must be compatible with software control. And we definitely see more trend towards virtualization. But and I think Stephen brought a really good angle into that one. You need to make sure which one would make sense. You don't virtualize everything, of course. So into the strategy to that one, that's a critical one. And that would sum it up on my side, Sophie.
Thank you, Stefan. Quick last comment, Stephen, before we conclude.
Sure. Just if there's a foundational requirement from the technology design community, it's that testing should be faster and cheaper, and certainly automation provides a pathway to both of those things, it would seem to me.
Perfect. Thank you. All right, so that's all the time that we had. So I really want to thank our two panelists, Stephen and Stefan, for your great insights. So I now would like to go to our more in-depth technical sessions that are starting in a few minutes. There will be a number of sessions, and some of them will actually have live demos that you can look at, and then you can also interact with the presenters. There are 4 parallel sessions that are 30 minutes each, and it will be repeated twice, so you actually have the possibility to attend 2. So if we look at the first one, which will be on how automation and test and measurement helps equipment manufacturers speed up fabrication, get lower yield, and also get better benefits and analytics with Louis and Annabelle. So that's the first session. The second session with Gwen and Sébastien will be about upcoming transceiver MSAs, and also cover the latest development on the Open RAN ecosystem. The third session with Gabriel and François, this one will discuss new approaches to really optimize the development to deployment cycle of silicon photonics transceivers. So that'll be a third session. And finally, our fourth session with Sébastien, François, and Lawrence. This session's all about PIC, or photonic integrated circuits, components, and how to test them. So again, thank you to our panelists, and thank you to all of the attendees, and looking forward to seeing you at the in-depth technical sessions. Have a good day.